Hey pre-calc, this is lesson 2 from section 1.6, and this is where we're going to get into how to solve not only rational inequalities, but also what happens when we have quadratic inequalities or even inequalities that just have a structure that's more complex than just single x's on both sides. So when you think about x squared minus x minus 6, the approach for computing this isn't really, I guess, intuitive. Like, it's not something where it's just like, oh, I know exactly what to do. A lot of times you look for the structure maybe in factoring if you can, or using the quadratic formula. What you saw on the first video when I found the zeros to compare to 0, and they were very helpful. That's what you're going to do. But you know what? I think what I want to do is show you how a graphing approach at least gives you some perspective on how the calculations will come about. So when you think about x squared minus x plus 6, or minus 6, you should be thinking, that's a parabola. That's one of these U-shaped figures. Okay? So with this equation, you can actually determine what, like, the place where it has an axis of symmetry with this little formula. Negative b over 2a will tell you where it splits apart. So what I'm doing right now is I'm saying, hey, can we draw the parabola to get some kind of perspective? 1 over 2 would be a half. So right here is where the parabola splits into two parts, which also tells us where the vertex is if we plug the half back in. So I said that negative b is 1 over 2 times 1. That's a half. A half is our x coordinate for our vertex. If you plug it in here, you get a fourth, minus a half, minus 6. So negative 6 and a quarter is where our 1, 2, 3, 4, 5, 6, 7. It does this. Okay? Now, what are the zeros? The zeros you would figure out by taking x squared minus x minus 6, setting it equal to 0. Either deploy the quadratic formula or use factoring to figure this out. Well, negative 3 times positive 2 gives me negative 6, and it adds up to give me negative 1. So guessing and checking, x here, minus 3 plus 2, we've got our solutions. It's going to be x2 equals 0, x minus 3 equals 0, subtract, add. We've got our zeros. It crosses the x-axis at negative 2 and at positive 3. Which you can kind of just fill in the gaps very informally. It's going to look like this. Okay, why am I doing this to you? Here's why. The statement, where is this parabola greater than 0, can be visualized as, where does this parabola exceed the x-axis? Where is it north of the x-axis? That's really what that inequality is saying. Where is the parabola bigger than 0? Where is it above the x-axis? In fact, I'd write that down if you're taking notes with my graphing here. Where is the parabola, or the quadratic, whatever you want to call it, above the x-axis? That's the equivalent question to these are basically asking the same thing. Okay, so it's doing that forever, which you can think of it from a leftmost perspective forever. It keeps going and going and going that way. So it would be, this part is negative infinity to negative 2. Not including it because it was greater than. And this is going to be 3 to infinity. Also not including that. So we know our answer. It's, sorry, you can't see it over the... It's negative infinity to negative 2 in union with 3 to infinity. Now, I don't want you guys to have to use graphs all the time. I just want you to have this as sort of like a backup strategy. And I get it. We maybe haven't graphed quadratics yet in this course. But let's go back over here, shall we? Here's how you can do it without the graphs. We already did step 1. Find critical numbers. Those are the zeros. Step 2. This is where we set up intervals and test them. So we're saying, hey, from negative infinity to negative 2, we should test that interval to see if it actually satisfies the original inequality. In this case, is it bigger than 0? We should also test negative 2 to 3, because maybe that satisfies the original. And the same thing with 3 to infinity. You test a point in between. So basically, what's less than negative 2? What's between negative 2 and 3? I always pick 0 when it's available. And then 3 to infinity, 4. So, you know what I'm going to do? I'm going to use this version that's already factored. So x squared minus x minus 6 is greater than or equal to 0. We can talk about this as x plus 2 and x minus 3. So then we can just plug the negative 3 in here, plug the negative 3 in there, and then it's sort of like we got a positive number times a negative number, or whatever the case may be. So plugging into this inequality right here, negative 3 plus 2 is a negative number. I'm multiplying it by negative 3 minus 3, which is a negative number. That's plus. We want plus. We want greater than 0. This is a part of the solution set. Makes sense. This one, you plug in 0. 0 plus 2 is a positive number, times 0 minus 3, a negative number. Positive times negative, negative, not greater than 0. 3 to infinity, try 4. 4 plus 2 is positive. 4 minus 3 is negative. Is also positive. A positive times a positive is a positive, which is greater than 0. So those are our two solutions. All right. Now, that seems like a daunting task because I unpacked it in several different languages kind of in mathematics. But really, if you say to yourself, can I find the zeros? Can I find the critical numbers? And can I set up these intervals and test it correctly? If you can do that, then the process doesn't have to be this lengthy. So that's how you solve quadratic inequalities. Yeah. Let's talk about rational ones. Now, I'm going to skip the graphing explanation because this graph is a heck of a lot more complicated than this one. All right, this one was just a U-shaped. This one's going to have asymptotes in several spots. It's going to have a horizontal asymptote. I don't think it's worth our time to kind of do the graphing investigation. So what we're going to do is the same procedure that we did over there. We're going to say, what are the critical numbers? And if you recall video 1, the critical numbers we did from that one were where the denominator equaled 0. we also have to take into account the zeros. Remember, we found the critical numbers that were zeros over there. We got to find the zeros for this one too. The denominator zeros are not really things that make the function zero. They're the things that make the function have like asymptotes and things like that. The top, though, is where it crosses the x-axis. So we need to find the numerator equal to 0 also. So let's do it. X squared minus 3x minus 10 equals 0. It's a quadratic. So use either the formula or factoring. I know that negative 5 times positive 2 is negative 10. That adds up to 3x, so it's x, negative 5, positive 2. Our critical numbers show themselves pretty quickly. So x equals negative 2 from this one, x equals positive 5 from this one. We've got a couple critical numbers. From the numerator, easy peasy, x equals 2. So we've got 1, 2, 3 critical numbers here. So we set up our intervals. Our intervals are going to be from negative infinity to the leftmost number here. All right, I think we can adjust. Yeah. So negative 2 is the smallest one. We would include a parenthesis because it's in the denominator. If something makes the denominator 0, that means that it's a domain issue. You can't divide by that number, so it can't be included. Right. So denominator crumbers, or critical numbers, I call them crumbers, they should have parentheses on them at all times. Denominator critical numbers have parentheses on them at all times. So negative infinity to negative 2. Negative 2 to 2, because that's the next one in numerical succession. Yeah? And actually, you know what? I'm not going to put a parenthesis on the 2. Since it was a greater than or equal to situation, the 0, the place where this whole function crosses the x-axis, can be included. Where is this graph above or equal to the x-axis? So, I want to make this very clear. The numerator does not always get brackets. It only gets brackets if the inequality symbol. So the numerator, follow the symbol for brackets or parentheses. Follow the symbol to decide between brackets or parentheses on the numerator critical numbers. All right, so we took a pit stop at negative 2, then again at 2. We got to do it at 5. So we got a lot to talk about. Parenthesis because it was in the denominator, and then 5 to infinity. Wow. Okay. So here's what I'm going to do. I'm going to rewrite. So pick a point in between. Negative 3, 0, 3, 6. And we're going to plug all of these values one at a time into this x. I'm going to rewrite x squared minus 3x minus 10 as the factored version because I do the math easier that way. And I think you guys do too. X plus 2 times x minus 5 is just the factored version of that polynomial on the bottom of the fraction. Yeah. So I'm going to plug negative 3 in for that x, that x, that x, and then make a decision. 0 in for this one, that one, and this one, and make a decision. Hopefully that makes sense. So I plug a negative 3 into negative 3 minus 2. I get a negative number. So, all right, I'm going to put it above because I created this mess below. So it's a negative divided by negative 3 plus 2, a negative times, because there's parentheses there, yeah? Negative 3 minus 5. Another negative. So it's a negative divided by a positive, which is a negative. So this one right here is negative. We want greater than or equal to 0, which would not be a negative number. Try 0. 0 minus 2, negative. Divided by 0 plus 2, positive. 0 minus 5, negative. It's a negative divided by a negative, which is positive. Oh, we want that. We want positive. We want greater than or equal to 0. So this will be part of our solution set. I'm just going to include it right here below. 3 minus 2, positive. Divided by 3 plus 2, positive. 3 minus 5, negative. It's a positive divided by a negative, which is negative. That's no good. And then the same thing with the last one. 6 in there is positive, positive, and positive. Whole thing's positive. So we would include that. And that would be your solution. All right, I'm going to stop this video here, and then on the next one, give you guys a few examples of rational, and then maybe one more of where you have to use factoring or, yeah, kind of a polynomial approach.